For centuries, Venus looked like a mystery hiding behind clouds, a planet wrapped in clouds so thick that no telescope on Earth could see through them. To early astronomers, it looked calm, bright, almost beautiful. But when the first real images finally came back from its surface, scientists realized something unsettling. The ground looked shattered. The light was dim and orange, as if the sky itself were burning. And the environment was so extreme that the spacecraft sending those images survived only minutes before dying. Venus wasn't just another rocky planet. It was something far stranger. And the images we received were only the beginning. Welcome to Simulation Hypothesis. This is where we question the grand promises of space and examine what the physics actually allows. No hype, no fantasy, just the reality hidden behind the beauty. If you're new here, subscribe and stay with us, because sometimes the most fascinating planets in our solar system are also the ones that challenge everything we thought we knew about how worlds evolve. For most of human history, Venus was a mystery. It is one of the brightest objects in our sky, often visible just after sunset or before sunrise. Ancient civilizations called it the morning star and the evening star, believing they were two separate celestial bodies. But even as telescopes improved, Venus refused to reveal its true nature. Unlike Mars or the Moon, whose surfaces could be seen clearly through telescopes, Venus remained hidden. The planet is permanently wrapped in a thick layer of clouds that reflect sunlight so efficiently that nearly 75% of the light hitting Venus is reflected back into space. From a distance, the planet looks smooth, featureless, almost peaceful. For a long time, many scientists imagined that beneath those clouds might lie a warm, wet world. Some early 20th century astronomers even speculated about tropical oceans or dense jungles hidden beneath the clouds. After all, Venus is often called Earth's twin. Its size is almost identical to Earth's. Its mass is similar. Its gravity is only slightly weaker than ours. And it orbits closer to the Sun, but not so close that life seemed impossible. If Earth and Venus formed from the same materials in the same region of the solar system, many researchers assumed they might have evolved in similar ways. But the truth would turn out to be far stranger. The first hints that something was wrong came in the 1950s, when radio astronomers began studying Venus using radar. Unlike visible light, radar waves can penetrate clouds. By bouncing radar signals off the planet and measuring the reflection, scientists were able to estimate Venus's surface temperature. The results were shocking. Venus was far hotter than anyone expected. Instead of mild tropical temperatures, the surface appeared to be hundreds of degrees Celsius. Later measurements confirmed the numbers. The surface temperature of Venus averages around 465 degrees Celsius. Hot enough to melt lead. Hotter than Mercury, even though Mercury orbits much closer to the Sun. This discovery forced scientists to reconsider everything they thought they knew about the planet. Something about Venus was trapping enormous amounts of heat. The answer turned out to be its atmosphere. Venus possesses one of the most extreme atmospheres in the solar system. It is composed mostly of carbon dioxide, with thick clouds of sulfuric acid droplets floating high above the surface. The atmosphere is incredibly dense. At ground level, the pressure is about 92 times greater than the pressure at Earth's surface. That is roughly equivalent to the pressure found nearly 1 kilometer beneath Earth's oceans. Imagine standing on a planet where the air above you weighs as much as the entire ocean pressing down. That is Venus. This dense atmosphere traps heat through a process known as the runaway greenhouse effect. Sunlight passes through the atmosphere and warms the surface. But the thick carbon dioxide layer prevents that heat from escaping back into space. Over millions of years, the heat built up. The oceans, if Venus ever had them, would have evaporated. Water vapor, itself a powerful greenhouse gas, would have intensified the heating even further. Eventually, the planet's climate spiraled out of control. Venus became a furnace. Even after scientists understood how extreme Venus was, there remained one huge problem. No one had ever seen the surface directly. The clouds were simply too thick. So space agencies began designing missions that could descend through the atmosphere and send back images before being destroyed by the intense conditions. The Soviet Union's Venera program became the first to achieve this. During the 1960s and 1970s, the Soviets launched a series of probes toward Venus, each one more advanced than the last. Many failed. The atmosphere crushed some spacecraft before they could transmit any useful data. Others melted under the intense heat. But eventually, in 1975, the spacecraft Venera 9 succeeded. For the first time in human history, a probe transmitted an image from the surface of another planet. And what it revealed was not what anyone expected. The image looked almost surreal. A rocky landscape stretched across the frame, filled with angular stones scattered across flat terrain. The sky appeared dim and orange, filtered through the thick atmosphere. The light level was similar to a cloudy day on Earth. But the ground itself looked strange. The rocks appeared fractured and sharp-edged, as if they had been broken apart by intense heat and pressure. The entire scene felt alien. Not a place shaped by water or weather like Earth, but something far more extreme. The probe that captured this image survived only about 53 minutes on the surface before its systems failed. Even with heavy insulation and cooling systems, the environment was simply too harsh. But those brief minutes changed our understanding of Venus forever. Later missions would send back even clearer images. The Venera 13 lander, which arrived in 1982, captured the first color photographs from the surface. These images revealed a landscape covered with reddish-brown rocks and dusty ground. Some rocks appeared layered or cracked. Others looked almost melted. The colors were distorted slightly by the thick atmosphere, but scientists could still study the geology. The lander also carried instruments to analyze the soil. Those instruments discovered that Venus's surface is largely made of basalt, a volcanic rock also common on Earth. This suggested that volcanic activity had played a major role in shaping the planet, and possibly still does. Radar observations from orbit later revealed even more surprising details. Unlike Earth, which is constantly reshaped by plate tectonics, Venus does not appear to have moving tectonic plates. Instead, the planet's crust behaves like a single rigid shell. Heat from the interior builds up beneath that shell over time. Eventually, massive volcanic events may occur that release enormous amounts of lava across the surface. Some scientists believe Venus may experience periodic global resurfacing events, where vast portions of the planet are covered in lava flows. Evidence for this idea comes from the relatively small number of impact craters on Venus. If the surface were billions of years old like the Moon, it should be covered in craters. Instead, Venus has far fewer. This suggests that the surface was completely resurfaced about 300 to 700 million years ago. In geological terms, that is relatively recent, which raises a fascinating possibility. Venus may still be volcanically active today. Recent observations have begun to support that idea. In 2023, scientists studying decades-old radar images from NASA's Magellan mission discovered changes in a volcanic vent on Venus. The images suggested that a lava flow may have occurred between two observations taken months apart. If confirmed, this would mean Venus is geologically alive, with active volcanism still reshaping its surface. But this discovery leads to an even deeper mystery. Because the strange environment of Venus, its crushing atmosphere, extreme heat, and volcanic activity, raises a question scientists are still trying to answer. How did a planet so similar to Earth become so radically different? And could the images we have already captured be hiding clues about what truly happened there? Because the more scientists study Venus, the more they realize it may hold a warning about how planetary climates can evolve. And the images we've received from its surface may only be the first glimpse of a world far stranger than we once imagined. One of the strangest things about Venus is something you would never notice just by looking at those first images from its surface. It's the way the planet moves. Almost every planet in the solar system rotates in the same direction as it orbits the sun. If you stood above the solar system and looked down, most planets spin counterclockwise. Venus does not. Venus rotates backwards. Astronomers call this retrograde rotation. On Venus, the sun rises in the west and sets in the east, the exact opposite of what we experience on Earth. But that isn't the only strange part. Venus also rotates extremely slowly. A single rotation of the planet takes about 243 Earth days. But its orbit around the sun takes only 225 Earth days. This means a day on Venus, from one sunrise to the next, actually lasts longer than a year on Venus. For a long time, scientists struggled to understand why. One possibility is that Venus may have experienced a massive collision early in its history, similar to the impact that created Earth's moon. Another idea suggests that tidal forces between the planet and its thick atmosphere gradually slowed and reversed the rotation over billions of years. But regardless of how it happened, this slow rotation has profound consequences for the planet's climate. On Earth, the rapid rotation of our planet helps distribute heat around the globe. Winds move between warm and cold regions, creating weather systems that circulate energy across the planet. But Venus behaves differently. Despite its incredibly slow rotation, its atmosphere moves astonishingly fast. The upper atmosphere of Venus completes a full rotation around the planet in only about 4 Earth days. This phenomenon is known as atmospheric superrotation. In other words, the atmosphere races around the planet roughly 60 times faster than the surface itself rotates. Powerful winds in the upper clouds can reach speeds of 360 kilometers per hour. No one fully understands why this happens. Some scientists believe the intense heating from the sun, combined with the dense atmosphere, creates powerful pressure gradients that drive these winds. Others suspect that complex wave interactions in the atmosphere amplify the motion. But whatever the cause, the result is extraordinary. The atmosphere of Venus is essentially a massive storm system that never stops moving. High above the surface, the clouds of Venus form thick layers composed mostly of sulfuric acid droplets. These clouds extend from about 45 to 70 kilometers above the surface. At those altitudes, conditions are surprisingly different from the inferno below. Temperatures in the upper cloud layers can range between 20 and 60 degrees Celsius, which is remarkably similar to conditions on Earth. This has led some scientists to consider a strange possibility. While the surface of Venus is completely hostile to life, the upper atmosphere might be far more hospitable. Some researchers have even proposed that microbial life could theoretically survive within those cloud layers. This idea gained attention in 2020 when a group of scientists announced a possible detection of phosphine gas in the atmosphere of Venus. On Earth, phosphine is often associated with biological activity. Its presence raised the possibility that unknown chemical processes, or even microbial life, might exist in Venus's clouds. However, the discovery remains controversial. Subsequent studies have questioned whether the signal truly represented phosphine. The debate is ongoing, but the fact that scientists are seriously discussing the possibility of life in Venus's clouds shows just how complex this planet may be. Meanwhile, down on the surface, Venus continues to surprise researchers in other ways. The planet's landscape is dominated by vast volcanic plains. More than 80% of the surface is covered by solidified lava flows. Some of these plains stretch for thousands of kilometers. Towering volcanoes rise above them, some reaching heights comparable to Earth's largest mountains. One of the most impressive is Mont Mons, a massive shield volcano that rises nearly 8 kilometers above the surrounding terrain. For years, scientists believed that most of these volcanoes were ancient and inactive. But new research suggests that may not be the case. When scientists recently compared radar images taken decades apart by NASA's Magellan spacecraft, they noticed something unusual. A volcanic vent near Mont Mons, appeared to have changed shape between two observations. The opening of the vent looked larger in the later image. Nearby terrain also appeared darker, as if fresh lava had flowed across the surface. If this interpretation is correct, it would mean Venus is still geologically active today. Active volcanoes could be reshaping the planet even now. This possibility has enormous implications. Volcanic eruptions release gases into the atmosphere, including carbon dioxide and sulfur dioxide. If Venus experiences periodic volcanic bursts on a large scale, those eruptions could help explain why its atmosphere became so thick and heat-trapping. It may also explain how Venus entered its runaway greenhouse state. Some models suggest that billions of years ago, Venus might have had oceans similar to Earth. But as the sun gradually grew brighter, increasing temperatures may have triggered more volcanic activity. The gases released from those volcanoes would have intensified the greenhouse effect. As the planet heated further, oceans evaporated. Water vapor accumulated in the atmosphere. And once the runaway greenhouse effect began, there was no way back. The planet transformed into the world we see today. A world where the surface temperature is hot enough to melt lead. A world where spacecraft survive for less than an hour. A world where the pressure at ground level feels like standing beneath a kilometer of ocean. And yet, despite these extreme conditions, Venus may still hold crucial clues about Earth's future. Our planet also relies on atmospheric balance to regulate temperature. Greenhouse gases play an essential role in keeping Earth warm enough to support life. But if those gases accumulate excessively, the balance can shift. Venus represents what happens when that balance collapses completely. It is an extreme example of how planetary climates can evolve when feedback loops spiral out of control. Studying Venus helps scientists understand not only how planets change over time, but how fragile planetary environments can be. Today, new missions are being prepared to return to Venus. NASA's DAVINCI and VERITAS missions, along with the European Space Agency's Envision spacecraft, are expected to launch in the coming decades. These missions will map the planet's surface with far greater precision, analyze its atmosphere, and search for evidence of recent geological activity. Some probes may even attempt to descend once again through the thick atmosphere to capture new images from the surface. Images far clearer than the ones sent back decades ago. Because even after everything we have learned, Venus remains a deeply mysterious world. A planet that began as Earth's twin, but evolved into something completely different. And those first images we received from its surface were not the end of the story. They were only the first glimpse of a planet that still refuses to fully reveal its secrets.